में vector can be multiplied in two different ways. Okay, so first is scalar product and second is vector product. Scalar product is also called as dot product. In scalar product, when we multiply the vectors, we get a scalar quantity. On multiplying, we get a scalar quantity. Vector product is also called as cross product. So when two vectors are multiplied and we are getting a vector quantity, then it is called vector product. Okay. Now because here we are getting a scalar quantity. So we differentiate them because यहाँ पे क्या हो रहा है, आप दो vectors को multiply कर रहे हो and you are getting a scalar quantity. Second case में क्या हो रहा है, you are multiplying two vectors and you are getting a vector quantity. तो इसको differentiate करने के लिए here we place a dot and here we place a cross. That's why sometimes we can also call this scalar product as dot product and this vector product as cross product. आ रहा है समझ? For example, if we have force and displacement. So force and displacement are both vector quantities. But when we multiply force and displacement, we get work, which is a scalar quantity. Similarly, if we have force and velocity on multiplication gives power, which is a scalar quantity, right? So here two vectors are multiplied and we get a scalar quantity. It's a scalar product of two vectors. While in vector product, when two vectors are multiplied, then we get a vector quantity. Another vector quantity, angular momentum. We get angular momentum by taking the vector product of r and linear momentum. We get torque by taking the vector product of r and force. Okay, so here we get a vector quantity. So to differentiate them, we just put a dot here. तो इससे क्लैरिटी हो जाती है कि हाँ ये डॉट प्रोडक्ट है, तो जो रिजल्ट आएगा वो स्केलर क्वांटिटी है, ये क्रॉस प्रोडक्ट है, तो जो रिजल्ट आएगा वो वेक्टर क्वांटिटी है. How do we take scalar product of two vectors? We simply multiply the magnitudes of the vectors and take the cosine of the angle between them. For example, if we have two vectors, vector p and vector q, and the angle between both the vectors is theta, then if we take scalar product of these two vectors, then we can write this as vector p dot vector q as magnitude of p magnitude of q into cos theta. तो हम क्या कर रहे हैं, जब हम दो वेक्टर्स का स्केलर प्रोडक्ट लेते हैं तो हम उन दोनों वेक्टर्स के मैग्नीट्यूड को मल्टीप्लाई करते हैं और उनके बीच में जो एंगल है, एंगल थीटा, उसका कॉस लेते हैं और उसको उसमें साथ में मल्टीप्लाई करते हैं. ठीक है, ओके. सो वेक्टर p डॉट वेक्टर q इज p q cos थीटा. क्लियर? to write everything. You've got the notes. Just write the keywords, the expressions only. Okay. So here theta is the angle between vector p and vector q and it is given by this. So because vector p dot vector q is pq cos theta, so we can write cos theta as vector p dot vector q upon magnitude of p into magnitude of q, or we can write theta as cos inverse of vector p dot vector q upon this. ठीक है? For example, if we multiply force and displacement, then we get work. Both force and displacement are vector quantities. But when we take the scalar product of these two vectors, we get a scalar quantity, which is work done. Similarly, if we have force and velocity, so if we are taking the scalar product of force and velocity, then we get power. Power is a scalar quantity. Okay. Now, what are the properties of scalar product? Dot product between two vectors obey commutative law. So if we are taking the dot product, so whether we write p dot q or we write q dot p, okay? So there is no difference between these two. In these two terms, we get the same answer. And dot product obeys distributive law as well. So if we have three vectors and we are taking the dot product of vector p with vector q plus r, so we can separately take the dot product and add them. We can take the dot product between p and q and then put a positive sign and then dot product of p and r. We can write like this. Similarly, if we, it is always a scalar, which is positive if angle between the vectors is acute. See, cos theta is positive in the first quadrant. After school to college we do, right? So cos theta is positive in the first quadrant. From 0 degree to 90 degree, cos theta is positive. So if theta is less than 90 degree, then we get a positive scalar. But if theta is greater than 90 degree, if it is obtuse, then it goes to the second quadrant. In the second quadrant, only sine, cosine, sine and cosec are positive. Rest other trigonometric ratios are negative. तो cos आपका क्या हो जाएगा? Negative हो जाएगा. ठीक है? Scalar product of two vectors will be maximum when cos theta is 1 because vector A dot vector B is AB cos theta. So it would be maximum when cos theta is 1. Cos theta 1 कब होता है? Cos theta 1 होता है cos theta 0 degree पे. तो अगर angle 0 degree होगा between the two vectors, if the angle is 0 degree, then the vectors are parallel to each other. ठीक है? This is vector P and this is vector Q. ये वेक्टर P है और ये वेक्टर Q है and angle between the vectors is theta. ठीक है? So we are writing vector P dot vector Q. Dot product of these two vectors as PQ cos theta. This is what we are doing. है ना? तो अब ये क्या है? We can write this as P into Q cos theta or we can write this as Q into P cos theta. See, if I resolve this vector Q into its horizontal and vertical component, then how will we resolve? This is the vertical component, है ना? And this is the horizontal component, right? So we can write vector Q as this as Q cos theta and this as Q sin theta. So we are taking that component of Q, Q's cos theta. Q cos theta is the component of Q which is along the direction of P. Similarly, if instead of resolving Q, we can also resolve P. So what if we resolve P? And if we resolve P into its rectangular components, then this is the vertical component and this would be the horizontal component, right? This would be the horizontal component of this vector. No? We are resolving vector P into its rectangular components. So if we resolve vector P into rectangular components, then we can write this component as P cos theta and this component as P sin theta. So you can see that when we are taking this Q into P cos theta, we are taking that component of P which is along the direction of Q. So P cos theta is along the direction of Q. So if vectors are orthogonal, then their dot product is 0. ठीक है? क्योंकि cos 90 डिग्री 0 होता है, तो अगर वेक्टर्स आपके ऑर्थोगोनल हैं, उनके बीच में एंगल 90 डिग्री है, तब उनका डॉट प्रोडक्ट 0 होगा. Because they are orthogonal unit vectors, I and J, angle between I cap and J cap is 90, angle between J cap and K cap is 90, angle between I cap and K cap is 90. So it's 0. We can write a vector like this, Px I cap plus Py J cap plus Pz K cap. And if we have another vector Q, so we can write vector Q as this in rectangular components. Yes. ये किया हुआ है हमने Qx I cap, Qy J cap, Qz K cap. So if we take the dot product, then we write like this. This is your x-axis, this is y-axis, and this is z-axis. Origin, ठीक है? So I cap is the unit vector along x-axis, J cap is the unit vector along y-axis, and K cap is the unit vector along k-axis, z-axis. ठीक है? तो अब यहाँ पे if we are taking the dot product of I cap and J cap, then we will write magnitude of first vector, magnitude of second vector, multiply by angle between these two vectors. And angle between I cap and J cap is 90 degree. So we'll write cos 90 degree. Cos 90 degree is 0, therefore it is 0. Similarly, you can take J cap and K cap. If you take J cap and K cap, again you will get 0. I cap and K cap, you will get 0. But what if we take the same unit vectors? If we take the same unit vectors, I cap dot I cap करते हैं अगर हम, तो उस केस में first we will write magnitude of first vector magnitude of second vector. Now, because these two unit vectors represent they are along the same axis, x axis. So ये क्या है, I cap यहाँ, एक और I cap यहाँ, है ना, they are along the same axis. So theta is 0 degree. So cos 0 degree आ गया आपका. इसका magnitude 1 होता है, unit vector है, it has unit magnitude. Unit vector है, unit magnitude, cos 0 degree is 1, so we'll get 1. So dot product of similar unit vectors is 1 and dot product of orthogonal unit vectors is 0. ठीक है, तो अगर आपके पास सपोज वी हैव vector p and vector q, this is given to you, right? And we have to take the dot product of these two vectors. तो क्या करेंगे हम? First we will multiply this pxi. इसे आप expand करते हो ना, expand करोगे, यहाँ पे आप q का expression लिखोगे, qxi cap, है ना, qy j cap, qz k cap. This is how we multiply ना. अगर आपके पास कोई टर्म्स होती हैं, नंबर ऑफ टर्म्स होती हैं, और फिर आप उसको मल्टीप्लाई करते हो, आप एक्सपैंड करते हो, राइट? फिर आप इसको लिखोगे, राइट? तो पी वाई जे कैप लिखोगे, फिर पी वाई जे कैप को इन सबसे मल्टीप्लाई करोगे अगेन, है ना? यही करते हैं ना हम. ऐसे ही आप थर्ड लिखोगे पी जेड के कैप, एंड देन यू विल मल्टीप्लाई दिस पी जेड के कैप विद ऑल दीज थ्री क्यू एक्स आई कैप. एक्सपैंडेड फॉर्म में भी मल्टीप्लाई लाइक दिस ओनली. तो अब इसमें यूल फाइंड आउट कि जो आपका ये है पी एक्स आई कैप और क्यू एक्स आई कैप है, तो ये आई कैप तो आपका 1 हो गया, तो यहाँ पे पी एक्स क्यू एक्स ही आएगा, ठीक है? लेकिन अगर आप इन दोनों को मल्टीप्लाई करते हो तो ये आई कैप डॉट जे कैप है, तो आई कैप डॉट जे कैप 0 हो जाएगा, ठीक है? क्योंकि ये आपका रेक्टेंगुलर यूनिट वेक्टर्स है और ये ऑर्थोगोनल है, इसलिए 90 डिग्री एंगल है. सिमिलरली आपका आई कैप डॉट के कैप भी 0 हो जाएगा, तो नो नीड टू राइट दिस, ठीक है? ऐसे ही यहाँ पे अगर आप जे कैप को आई कैप से करते हो तो 0 आएगा, तो वी विल नॉट राइट. अगर आप जे कैप को जे कैप से करते हो तो यू विल गेट 1, तो वी कैन राइट दिस पी वाई क्यू वाई. सिमिलरली अगर आप इसको आप इससे करोगे, अगेन यू विल गेट 0, जे कैप डॉट के कैप इज 0. ऐसे ही यहाँ पे 0 आएगा, नो नीड टू राइट, है ना? यहाँ पे भी 0 आएगा, नो नीड टू राइट, के कैप डॉट जे कैप, है ना, के कैप डॉट जे कैप 0 होगा, ठीक है? और अगर आप के कैप को के कैप से मल्टीप्लाई करते हो तो यू गेट 1, तो फिर आपको 1 आता है, तो मिलता है, तो फिर यू कैन राइट दिस. इसलिए जब हम डॉट प्रोडक्ट लेते हैं तो हम आई कैप वालों को आपस में इनके जो कोफिशिएंट्स होते हैं मल्टीप्लाई कर देते हैं, इन दोनों को मल्टीप्लाई कर देते हैं और इनको मल्टीप्लाई करके ऐड करके लिखते हैं. नेक्स्ट वी हैव क्वेश्चंस बेस्ड ऑन दिस. डॉट प्रोडक्ट ऑफ वेक्टर्स इज अ वेक्टर, स्केलर, टेंसर, none of the above. It's a scalar quantity. A force F acts on a particle and displaces it over. You have to find work done. A force F is equal to 6 I cap minus 8 J cap Newton acts on a particle and displaces it over 4 meter along the x-axis and then displaces it over 6 meter along the y-axis. The total work done during two displacement is. Find the answer. And then displaces it over 6 meter along y-axis. Okay, okay. And then displaces it over 6 meter along y-axis. Displaces it over 4 meter along x-axis and then displaces it over 6 meter along y-axis. Now we have to find total work done. For this, we'll find displacement first. This is the displacement. Yeah. Write the coordinates of this point because this is the final position. No? This is the initial position. Initial position and this is the final position. First, the particle goes 4 meter towards x-axis, then it goes 6 meter towards y-axis. We can write the coordinates of this point as 4, 6, and this point is P, and displacement कितना आएगा इसका? Initial position is this, final position is this, so we'll write displacement as OP vector. So this is 4 I cap plus 6 j cap. Now take the dot product. So work done is equal to vector F dot vector S. It is equal to 6 I cap minus 8 j cap 4 I cap plus 6 j cap. I cap को I cap से multiply करोगे because I dot j 0 है, j dot I 0 है, no need to write. So you write just 24 minus 8 6 are 48. So it's minus 24 joule. This is how you're supposed to write. Okay, next we have this vector component. So this we have discussed already, that q cos theta is the component of q along the direction of vector p. Okay, so component of q along p is q cos theta. कोई वेक्टर है, जैसे वेक्टर a है, ठीक है, इसके हमने रेक्टेंगुलर कंपोनेंट्स में रिजॉल्व करते हैं, देन वी फाइंड द एंगल, उसका x एक्सिस के साथ एंगल कितना बन रहा है ना, ये y एक्सिस है, ठीक है, तो x एक्सिस के साथ इसका जो हॉरिजॉन्टल कंपोनेंट आता है वो a cos थीटा आता है, y एक्सिस के साथ जो इसका वर्टिकल कंपोनेंट आता है वो a sin थीटा आता है. दिस इज हाउ वी राइट, है ना, तो ये ax से भी डिनोट कर सकते हैं, ax is equal to a cos theta, ay is equal to a sin theta. This is how we write. So for vector q, so don't look at this p now, just look at vector q only. फोकस आपका बस वेक्टर क्यू पे होना चाहिए, किसी और चीज को देखना ही नहीं है, हमने सिर्फ वेक्टर क्यू को देखना है. अगर इसको आप कंपोनेंट में रिजॉल्व करोगे, इट इज मेकिंग एन एंगल थीटा विद एक्स एक्सिस, है ना, तो यू कैन राइट दिस कंपोनेंट एज क्यू कॉस थीटा. यस, तो दिस इज द हॉरिजॉन्टल कंपोनेंट. नो, हॉरिजॉन्टल कंपोनेंट है ना ये इसका. आप पी को बॉदर मत करो, आप बस क्यू को बॉदर करो. हम बस क्यू को देख रहे हैं, हम पी को नहीं देख रहे हैं, ठीक है. अभी हम सिर्फ क्यू को देख के हमने उसको कंपोनेंट्स में रिजॉल्व कर दिया, तो हमें ये समझ आ गया कि हाँ ठीक है, ये इसका हॉरिजॉन्टल कंपोनेंट है और ये इसका वर्टिकल कंपोनेंट है, ठीक है. अब लेकिन ऐसा तो नहीं है कि दिस इज नॉट द ओनली वेक्टर वी हैव टू डिफरेंट वेक्टर्स. तो वी हैव वेक्टर पी आल्सो. तो वेक्टर पी का डायरेक्शन वही है जो क्यू कॉस थीटा का डायरेक्शन है ना. तो अब ये क्या बोल रहे हैं, कंपोनेंट ऑफ क्यू अलोंग पी, मतलब क्यू का वो कंपोनेंट जो पी की डायरेक्शन में है. तो पी की डायरेक्शन में वी हैव दिस कंपोनेंट ऑफ क्यू, इट्स क्यू कॉस थीटा, ठीक है. दैट्स व्हाई वी हैव रिटन q cos theta. Now because we know the dot product of two vectors, if we take the dot product and the angle between the vectors we know it's theta, so we simply write magnitude of first vector, magnitude of second vector, and cos of angle between them. This is how we write, because now we are dealing with this q cos theta only. So we just eliminate this portion q cos theta. We'll remove this p, we'll move this p to the other side, and we get q cos theta as vector p dot vector q upon p. You can write this. And one more thing, we know that if we have a vector and we want to write a unit vector, how do we write a unit vector? We write the vector and divide this by the magnitude of the given vector. This is how we write the unit vector. So here also we have the same thing. Now we have vector p and its magnitude in the denominator. So when we divide any vector with its magnitude, we get the unit vector. So this is p cap dot, and this is a scalar product. Doubt? Clear? अच्छा, अब ये क्या कह रहा है, देखो कंपोनेंट तो क्लियर हो गया, बट इसमें अब एक वी हैव एडेड वन मोर टर्म हियर, वेक्टर. मतलब यहां तक तो ये मैच कर रहा था, जो ये वाला पार्ट है और जो ऊपर वाले सेंटेंस में ये वाला पार्ट है, ये तो मैच कर रहे हैं ना आपस में, कोई इशू नहीं है. प्रॉब्लम क्या आ रही है, वेक्टर लग गया आगे. वेक्टर का मतलब ये है कि ये आपने जो फाइंड किया, ये तो आपने उसका मैग्नीट्यूड फाइंड किया, क्यू कॉस थीटा, जो आपने क्यू कॉस थीटा फाइंड किया है, ये तो मैग्नीट्यूड है ना, ये तो मैग्नीट्यूड है. डायरेक्शन थोड़ी स्पेसिफाई कर रहे हैं इसमें हम, बिकॉज़ ये स्केलर प्रोडक्ट है. तो स्केलर प्रोडक्ट में स्केलर क्वांटिटी आएगी, डायरेक्शन तो आएगी नहीं. तो वी नीड टू ऐड द डायरेक्शन नाउ बिकॉज़ वी आर टेकिंग द वेक्टर कंपोनेंट. वेक्टर कंपोनेंट of q cos theta, what is the direction of q cos theta? It is the direction which we have p, the same direction which p has, and they have the same directions. So q cos theta and vector p, they both are in the same direction. So we will write p cap with q cos theta. Initially we had taken only q cos theta, Now we have written p cap with q cos theta because q cos theta represent the magnitude only. It does not represent the direction. And now we have added direction. So magnitude plus direction forms the vector. तो अब ये जो हमारा वेक्टर लिखा हुआ है टर्म आगे इसको हमने डिफाइन कर दिया इससे क्योंकि वी हैव एडेड डायरेक्शन टू इट एंड डायरेक्शन क्या होगी जो क्यू cos थीटा की वही डायरेक्शन है जो पी की डायरेक्शन है एंड हाउ डू वी राइट डायरेक्शन यूनिट वेक्टर गिव्स द डायरेक्शन ऑफ एनी वेक्टर दैट्स व्हाई रिटन पी कैप इजी थोड़ा थोड़ा आया या अच्छे से 100% आया चलेगा धीरे धीरे आ जाएगा ठीक है कंपोनेंट ऑफ पी अलोंग क्यू अब पी का कंपोनेंट निकालना है अलोंग क्यू अगेन वी विल टेक द रेक्टेंगुलर कंपोनेंट है ना ऑफ पी सो this is the vertical component and this is the horizontal component. Now look at vector p only, don't look at q now. ठीक है q को बॉदर ही नहीं करना हमने हम बस अपना p को ही बॉदर करेंगे वी डीलिंग विद p नाउ ठीक है सो दिस इज थीटा सो दिस इज द this is the horizontal component it is p cos theta and this is the vertical component it is p sin theta. Now component of p along q p का component q की डायरेक्शन में क्या है p cos theta again because vector p dot vector q is pq cos theta तो अब आप यहां से p cos theta को एलिमिनेट कर लोगे तो p cos theta is equal to vector p dot vector q move this q to the other side ये डिवाइड हो जाएगा ठीक है अब वेक्टर q by q is vector upon magnitude of the vector is the unit vector so we can write vector p dot q cap clear any doubt so this p cos theta is this again it is only magnitude. What if we have to find vector component of p along q then if we have to find vector component of p along q then we'll add direction to it. It's vector p up dot q cap right then we'll add direction to it and direction is that of direction of p cos theta and direction of q they are same so we can write q cap so this is the dot product and now we will write q cap. Q cap gives the direction and this is the component of p along q it's p cos theta or vector p dot q cap clear doubt component of p along vector q is p cos theta it's vector p ये आ गया आपका इसके बाद आपका ये आ जाएगा vector p dot q cap this we had discussed and similarly we can find the vector component of p along q it's this easy a constant force 2 I cap plus 3 j cap plus 4 k cap newton produces a displacement of 2 I cap plus 3 j cap plus 4 k cap meter. What is the work done? How do we find work done? F dot S. Sir. Work done is vector F dot vector S. So first write F. It's 2I plus 3J plus 4K dot. Now write S. It's 2I cap plus 3J cap plus 4K cap. We measure work in joule. Write the unit. Now, when we take the dot product, how do we take dot? We consider only I cap coefficients and do not multiply I cap and j cap because we get 0, no need to multiply. So it's 2 into 2 I cap dot I cap. So we can write 2 to the 4 plus 3 3s are 9, 4 4s are 16 joule. What is the answer? It's 29 joule. Write the answer. Vector A is 2 I cap plus 3 j cap minus 6 k cap, and we have another vector, vector b, and it is 3 I cap minus m j cap plus 6 k cap. And it is given that these two vectors are perpendicular. Vector A is perpendicular to vector B. And question is that we have to find the value of m. So this. When two vectors are perpendicular, then angle between the vectors is 90 degree. Cos 90 degree is 0. So if we take the dot product of these two vectors, then we'll get 0 because AB cos theta hota hai, right? Now take the dot product and put it equal to 0. So this implies 2 I cap plus 3 j cap minus 6 k cap dot 3 I cap minus m j cap plus 6 k cap is equal to 0. Now multiply these two. 2 into 3, 6. 3 multiplied by minus m is minus 3m. Minus 6 multiplied by plus 6 is minus 36 is equal to 0. This implies minus 3m minus 30 is equal to 0 and m is equal to minus 10. Write the answer. Vector A is equal to 3 I cap plus 4 j cap. Find the component of vector A along the direction of 2 I cap minus 3 j cap. Karo. Vector A is given. Vector A is equal to 3 I cap plus 4 j cap. And let this vector be vector B. Okay. Let this vector be vector B. So vector B is 2 I cap minus 3 j cap. Now we have to find component of vector A along the direction of B. So let the angle between these two vectors be theta. This is vector A and this is vector B and the angle is theta. We have to find component of A along the direction of B. Component of A along the direction of B is A cos theta. Yes. And see, we have to find vector component. So how will you find vector component? Tell me. Very nice, shabash. Vector component of A along the direction of B. ये निकालना है ना? So we'll write A cos theta and we will write the direction of B. B cap. Okay, and A cos theta. See, we'll take the dot product. When we take the dot product, we get AB cos theta. So from here we can get A cos theta. So A cos theta is vector A dot vector B upon B. Yes. For this, we need to find magnitude of vector B first and dot product of these two vectors. So let's find dot product of these two vectors. Vector A dot vector B is equal to 3 I cap plus 4 j cap and vector B is 2 I cap minus 3 j cap. 3 2s are 6 plus minus minus 4 3s are 12. It is minus 6. Now find the magnitude of B. Magnitude of B is square root of 2 square plus minus 3 square, ऐसे ही लेते हैं ना मैग्नीट्यूड, है ना। तो 4 plus 9 हो जाएगा, तो ये आ गया √13, एक कम हो गया. दिस इज योर a cos theta. Okay, so a cos theta is a cos theta dot b cap. This is what we have to find out, right? So b cap is vector b upon b. Vector b is 2i cap minus, you're not writing, 3j cap, and b is √13. Okay, now we will put all these values here. So a cos theta is this, a dot b is -6 and b is √13, and this b cap is, what's going on, 2i cap minus 3j cap upon √13. So we can write this as -6/13. In the bracket we have 2i cap minus 3j cap. This is the answer. The vector f is 3i cap plus 4j cap minus 5k cap, and vector d is 5i cap plus 4j cap plus 3k cap unit. This is also in unit. Okay. Now we have to find angle between f and d. So there are two things we have to find out. To find, number one, angle between vector f and vector d, and number two, projection of f on d. Projection of vector f on d. This is what we have to find out. Let's start with the first part. It's easy. First part is easy. You can do easily, because we have to find angle between these two vectors, and we know that if we take the scalar product of two vectors, then we can write magnitude of first vector, magnitude of second vector, multiply by angle between the vectors, right? So if this is vector d and this is vector f, and angle between these two vectors is theta, so we can take the dot product and write like this. So from here we can find cos theta. This implies cos theta is equal to vector f dot vector d divided by magnitude of f into magnitude of d. Okay, so let's take write the vector, first vector first. It's f, vector f. It's 3i cap plus 4j cap minus 5k cap, and second vector is 5i cap plus 4j cap plus 3k cap, and in the denominator first we will write magnitude of vector f. And how do we take the magnitude? Yes, we take the squares and in the square root, है ना, we write. So squares first and then we'll add them, है ना, coefficients को add करके 3 square plus 4 square plus minus 5 square, and similarly for this vector d we can write 5 square plus 4 square plus 3 square. Yes, now because when we take the dot product we simply multiply I component together, jj together, kk together. This is what we do. So 3 5s are 15, 4 4s are 16, plus minus 5 3s are 15, and in the denominator we have this. So 25 plus 9 plus 16, it's 50, √50, and here we have 25 again √50. Okay, so this is 16 upon 50. 16 upon 50. Or we can write this as 8/25. Okay. So, or in decimals, we can write 0.32. So this is the value of cos theta. Okay. If you, because you have to find angle, so you can write theta is equal to cos inverse 8/5, 25, or you can write theta is equal to cos inverse 0.32 डन होता है हमारा जो आपका वेक्टर f डॉट डी कैप आया है, ठीक है, एंड देन एड दिस, ठीक है, do it. Okay, so this is 16 by root 50 and d cap is 5 I cap plus 4 j cap plus 3 k cap divided by root 50. So after root 50 is 50, so it's 16 by 50. And here we have 5 I cap plus 4 j cap plus 3 k cap. This is 8 by 25. Okay, we can write 8 by 25 to bracket 5 I cap plus 4 j cap plus 3 k cap. This is the answer.